Welcome to Exponential Equations. Let's begin. So let's remember the old exponent rules. When we were multiplying terms, x to the 6 times x squared, we would add our exponents, right? So multiplying terms, just add the exponents, so we get x to the 8th. When we divided our terms, so x to the 4th divided by x cubed, we would subtract our exponents. So we have x to the power of 1, or just x. And then our other rule was if we had x squared to the power of 3, so power to a power, we would multiply the exponents. So that's x to the 6th. So multiplying terms, add exponents, dividing terms, subtract exponents, power to a power, multiply exponents. Same rules that we're doing now, except because we're an exponential unit, right? Remember our parent exponential functions y equals 10 to the x. So now we're going to have x's in our exponent, but the rules don't change. So if I had 3 to the power of x times 3 to the power of 2, I end up with 3 to the power of x plus 2. Because remember, when you multiply terms, you add your exponents. So likewise, when I'm dividing terms, if I had 3 to the power of 3x divided by 3 to the power of 2x, I end up with 3 to the power of x, because when you divide terms, you subtract your exponents. And again, using the same power to a power rules, but now I have an x in the exponent. If I had 3x to the power of 2x, I'm multiplying my exponents, so I end up with 3 to the power of 2x squared. So again, power to a power, multiply exponents. So the same rules apply. We're just going to have x's in our exponents now. The rules don't change. So there are two rules that you've got to remember with exponential equations. And the first one is that if both sides of an equation have the bases that are equal. So if your bases are the same, your exponents must also be equal. So for example, this is a simple example. If you have 3 to the power of x equals 3 to the power of 2, then x must be 2. If my bases are the same, then I can set my exponents equal to each other. The second rule is if your exponents are equal, then their bases must be equal. So it's just switched from the first rule. So another simple example, if I have x to the power of 4 equals 3 to the power of 4, if my exponents are the same, then I can set my bases equal to each other. So x must be 3. So again, if your bases are the same, your exponents must be the same or equal to each other. If your exponents are equal, then your bases must be equal to each other. So let's do a couple of examples of what we just said. So if I have 2 to the power of x plus 4 equals 2 to the 5th power, because my bases are the same, I can set my exponents equal to each other. So x plus 4 equals 5. So that means x equals 1. So another example, let's take that one step further. If I had 2 to the power of x plus 3 equals 32. This is where it gets a little bit tricky. They don't have the same bases like these did. So let's make it have the same base. I know that 32 is 2 to the 5th power. You could also check that on your calculator if you didn't know that right off the top of your head. So now if I change 32 to 2 to the 5th, now my bases are the same. So now I can set my exponents equal to each other. So x plus 3 equals 5. So x must be 2. So if your bases aren't the same, make them the same. Okay, so I'll write that here. If your bases are not the same, make them the same. So if we look at this other example, and we'll take it a step further. If I have 3 to the power of 2x plus 5 equals 27 to the power of x. And my bases aren't the same, so let's make them the same. 27 is 3 cubed. So what I'm going to do is change 27 to 3 cubed. So I'll rewrite it here. So I have 3 to the 2x plus 5 equals 3 cubed, but remember it's still to the power of x because there was that x there. All I did was change the 27 into 3 cubed. And my rule for power to a power is to multiply my exponents. So I end up with 3 to the 2x plus 5 equals 3 to the 3x. Now I have the same bases, so I can make my exponents equal to each other. And then when I rearrange that, I get that x equals 5. So don't forget, if your bases are the same, set your exponents equal to each other. If they're not the same, make them the same. So look at this last example and see if you can figure out what to do here. 9 to the 2x minus 1 equals 27 to the x plus 4. So I'll go through and explain it. The bases aren't the same. I can't turn 27 into 9 squared or 9 cubed or anything like that. So I have to change both of them so their bases are the same. So I'm going to change 9 into 3 squared and 27 into 3 cubed. So here's 9 becomes 3 squared, but it's still raised to the power of 2x minus 1. 27 becomes 3 cubed, but it's still raised to the power of x plus 4. Now I have power to a power rules. So I have 3 to the 4x minus 2 equals 3 to the 3x plus 12. So my bases weren't the same, I made them the same, and now that they are the same, I can set my exponents equal to each other. So 4x minus 2 equals 3x plus 12, so that gives me x equals 14. That's all for now. Bye.